All right, so in the lab coming up this week, we are given the problem of trying to determine which substance lose or gain heat the most when they change temperature. Okay, and so we're going to be comparing 5 different substances: aluminum, zinc, copper, iron, and water. And what we want to do is we want to identify, well, if they change 5 degrees Celsius, do they all lose or gain heat the same amount? Does it take the same number of joules of energy to change zinc 5 degrees versus copper versus iron? So we want to compare these, and we need to measure this experimentally. So what we're going to do is we need to first have a background in this idea of heat transfer. So what I'm going to do is I'm going to say, well, what if we go ahead and we have a hot object, okay? And we go ahead and we see that we also have a cold object. Okay, so we have hot and cold objects. So I'm going to call this cold object sitting at Tc, and I'm going to call this hot object sitting at Th. Okay, so this is the temperature of the hot object, temperature of the cold object. Now when they're separate, they're just going to stay at the temperatures that they are. Now what if we go ahead and we bring these close and we go ahead and put them in contact with each other? Okay, and so we take our cold object and our hot object and we bring them in contact with each other. Once we do that, we'll see they will end up getting to the same temperature. Okay, so I'm just going to call this the final temperature. Okay, so we start with this cold object, hot object, we bring them close to each other. They end up getting to what we call thermal equilibrium, which means they're sitting at the same temperature. Okay. Now in order for us to do this, we would say, well, does the hot object lose the same amount of heat as the cold object? Right? Maybe do they change the same temperatures? Right? So if we're looking at our hot object, the change in temperature of our hot object is going to be equal to the final temperature that it ends up minus the temperature it started at. Right? And if we did the same thing for our cold object, we would see that our cold object, the change in temperature that it undergoes is going to be the final temperature minus the temperature that it started at. Okay? These are probably not going to be equal to each other unless they lose heat or gain heat the same amount. Okay? But these are things that we can measure in a lab. We can measure temperature that they start at, and we can measure temperature that they end up at. But we want to be able to indirectly measure how much heat they actually lose or gain. Okay? Well, the only way we can't directly measure heat. Remember, heat is a transfer of kinetic energy. We can measure changes of temperature, but we can't directly measure heat. So how do we actually measure the transfer of heat that goes on here? So we see we are able to measure, well, the amount of heat that is lost by our hot object here is equal to the mass of that hot object times the specific heat of that hot object times the change in temperature that that hot object undergoes. Okay? And so we can go ahead and we see, well, let's go ahead and look at our cold object. So again, we can calculate the amount of heat, in this case gain, because our cold object is going to increase in temperature, is the mass of that cold object times the specific heat of that cold object times the change in temperature that that cold object undergoes. And then we would think, well, how are these two things related to each other? Well, we go back to the first law of thermodynamics, which states energy cannot be created nor destroyed, right? So we must conserve energy. We're transferring kinetic energy. So that means that the heat that our hot object, the change that it undergoes is equal to the inverse and opposite of our cold object. Okay, and so we see, well, does this make sense kind of numerically or mathematically? We go back to our temperature of a hot object. We see that this is end up going to be a negative value. This temperature change here should be a positive value because we're going to increase in temperature as we go from here to here. We're going to decrease in temperature as we go from here to here. Okay? And so now we see we can relate these two things. We now have a relationship for a hot object and a relationship for a cold object. Now, in order for us to actually determine how much heat is gained or lost by one of these, well, we can know our mass, that's measurable in the lab. We can measure our temperature change, so we can get both of those in both of our lab, in a lab experience. The only thing we don't know is maybe our specific heat. So we must have one of these that we know our specific heat. Well, once we do that, we can then compare those two. Okay? Now the trick is in the lab is actually figuring out how do we measure the temperature of something well and know it's a specific temperature. How do we easily measure the final temperature? Okay? These are things that we're going to think about as you kind of think about how you're going to work through this lab. Okay, so hopefully now we have a basis of this idea. We're going to have something that's hot, something that's cold, bring them in contact with each other. We can now measure those temperature changes, which gets us down the road to being able to compare our heats. And then that also gives us the ability, kind of importantly, to be able to compare our specific heats. Because maybe that specific heat relationship has something to do with how we can compare how much heat is gained or lost when they change 1 degree Celsius, 2 degrees Celsius, etc. Okay? So I hope you have a good basis now as you kind of move into lab. Think through an idea of how you want to do this lab. It's a fun lab, gets you thinking. I hope you enjoy it.